Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of OpenShift TV. I am Chris Short, Principal Technical Marketing Manager here at OpenShift at Red Hat, and I'm joined today by the one and only Andrew Sullivan, as we called him yesterday, the most cuddly curmudgeon at Red Hat.
Hey, thank goodness there's only one of me, as my wife will attest.
No, we do appreciate you having the show. This is the show for OpenShift admins, right? Like we have a developer experience office hours. Now we have an admin office hours. So the idea is that we're going to answer some of those running OpenShift at scale things. And today we are talking about what, Andrew?
So, in the lack of audience questions, which I do want to remind everybody that this is kind of an AMA, right? It's driven by you all and your participation. Notice I said you all, not y'all. I'm trying to eliminate some of my Southernisms, at least while I'm on stream.
Wow.
I know. Yeah, I don't know if you all is any better, but anyways,
Mm.
so in lack of any questions coming from the audience, which we definitely want, regardless of topic, if we don't know
Yeah.
the answer, then we will certainly take a note and follow up.
Mm-hmm.
You can always reach out to me on Twitter for follow-ups, as well as emailing me at Red Hat if you so choose.
Yes.
Super easy. First name dot last name.
Yeah.
But in
I'll
the
drop your Twitter
absence,
handle in.
thank you. So in the absence of participation, I kind of wanted to talk about CoreOS, or more specifically, I should say, Red Hat Enterprise Linux CoreOS, the operating system used by OpenShift.
Yes. It has a lineage behind it, though, right? Like CoreOS was a company that we acquired. CoreOS was actually CoreOS Tectonic was my first Kubernetes distribution like ever, and like to put into like a data center kind of thing. And yeah, the Red Hat acquisition of CoreOS gave us a lot of their technologies and ideas and tooling, and operators are something that we've embraced wholeheartly, and that totally came out of CoreOS. And then the ideal of this, completely immutable operating system is a CoreOSism, for lack of a better term, right?
Yes, but there's also some other things that are related from the Red Hat portfolio.
Absolutely. Right.
So yeah, to your points, I have a little bit of history there as well. I went to the very first of the Tectonic conferences way back.
Nice.
I'm trying to remember when it was, 2015,
15, yeah.
2016. It was
Yeah.
also the very first meeting of CNCF. I was in the room there, which was fun. But yeah, that was up in New York City, I think in the Times building.
Yeah.
I got trapped in the elevator because it was one of those ones where you push the floor outside and it tells you which car to go to. And I didn't realize this and just blindly walked onto one of the cars and went for a ride.
Fun. I've done that before for job interviews. That's probably just as entertaining. Weird.
Yeah. So, hey, it was fun, but
Yeah.
New York City, I like New York City. That was my
Yeah, there's not to like about New York City.
5th or 10th or 15th time in New York City.
Yeah.
So it was fun.
Yeah.
Anyway, so yeah, CoreOS, the company, which was acquired by Red Hat a little over 2 years ago, right at 2 years ago, something like that now. We took their technology, so the two big ones being Tectonic, which was the kind of it turned into the OpenShift administrator interface, and CoreOS itself, so CoreOS, the operating system. And then we took all of that, concepts, ideas, technology, implementation, and merged that with what Red Hat called Atomic. Right. So both of them have that same principle of, immutability, of, the whole AB RPMOS tree, switching between versions. Right. Everything is done in one kind of holistic method. And the outcome of that was, and operators. So operators were originated at CoreOS as well. And you'll notice that those three components play pretty major roles in OpenShift 4. You could pretty easily argue or state that those were, especially operators were the driving force behind, the major version change, OpenShift 3 to OpenShift 4. I'm sure that somebody from engineering would say, "Oh no, there was these other 10,000 things."
Oh yeah,
Right?
there were 10,000 things, but
Yeah.
yeah.
So, but from a high level, right? The operators, especially, were a huge change in
Hmm.
from OpenShift 3 to OpenShift 4. I remember back in the OpenShift 4 RC days, which remember 4.0 was never actually released.
Right.
We did a hackathon, and it was one of those, wow, there's a lot of change here. Like I had to relearn a lot of things from scratch, basically.
Well, it kind of felt like that rel 6 to 7, 7 to 8 jump, right? Like it's kind of the same feeling, right? Like we adopt to embrace new technologies, and then here we go. Welcome to the new world.
So yeah. So I see Waleed is asking about bottle rockets. So
Ooh,
I am not super familiar with bottle rocket at this point. Like I know the principle behind it. I kind of know what they're doing, but from an implementation low level, right? Can I explain the differences? I don't know. I have not had the time nor opportunity to go through and
well,
dig
this
into that.
is when we get to do it live, right? No,
Um, I
no.
don't even know.
I got it. I
Yeah,
got you. Hang on.
that
Here we go.
implies
Let's
that
do
I
it
know how
live.
to
Let's
get
do it live.
started with bottle
I
rocket.
got you. Here we go. What is Bottle Rocket? Bottle Rocket is a new Linux open source OS that is purpose built to run containers. Okay, so it sounds like the same thing. Small footprint. How is Bottle Rocket different from Amazon Linux, which will probably answer a lot of our questions? Amazon Linux is a general purpose, so this uses the RPM package manager containers. Bottle Rocket does not have a package manager, and software can only be run as containers. Update to Bottle Rocket are applied and can be rolled back in a single atomic step, which reduces update errors. Huh. Okay. So how do they do that? Of course, they don't link that here.
Yeah, I
Bottle
mean,
Rocket
on the
documentation.
surface, it sounds very similar,
That
right?
sounds very, very similar. Yeah.
Um,
Let's see.
you know,
Oh, it's an operator. They update things with an operator. Imagine
yeah.
that. Huh.
So things like there
Yeah.
is no SSH, right? You use the control container.
Right.
So very much like
Yeah.
we have, we do the OC debug command against nodes. That's
Mm-hmm.
the one and only entry point in there. So,
Mm.
getting down into details again, I don't know the details, so I'd have to spend some time digging in there. I don't know if our and I should know this, but I don't know if our competitive folks have had any opportunity to dig into it or anything like that. So,
No, that's a good point. But like, maybe I should ping them and just bring them on and say, hey, what is the difference between like AWS EKS and OpenShift kind of thing? Maybe there should be a competitive or not competitive show, but maybe, like an XKS versus OpenShift show kind of thing, right? Like, what are the differences? Where are the sharp edges in comparison kind of thing? Not a
yeah,
bad idea.
on one hand, maybe. On the other hand, the difference is from Andrew's perspective. When we look at all of those other Kuberneteses, I'm going to keep using that till it becomes a thing.
Mm-hmm.
They are quote unquote just Kubernetes. I say quote unquote because just Kubernetes is encompassing a lot. But OpenShift adds on a lot of value add, right? There's a lot
Yeah.
of things that we do on top of there in addition to the standards Red Hat, um,
Mhm.
support, testing, validation, security, etc. Um,
So we've got some other
okay.
questions. And Waleed has a continuation, but we'll get back to that well, let's do that first. He says, no worries. If I would like to change the install config.yaml to a single node, what do I need to make the router run on the master?
I'm actually going to jump up to the question from Mudasar because he asked
Yeah.
first.
Okay. Sure.
Um, Red Hat OpenShift has vendor validation certification. If I want to validate a CNF from platform perspective, does vendor validation have some test suite to achieve that? I would assume yes, but I do not know for sure. We would have to put you in contact with the certification team. Um,
Yeah.
and if you want to reach out either to me or Chris, we can put you in contact with the right people to get
Yeah.
all of those answers. I can speak from a operator certification perspective, from a container certification perspective. There's a number of things that you would want to be aware of. Just as soon as I can find the right link here, I will post it into the chat.
Ah, the great tab hunt.
I know. So the link that I just posted there is our partner certification guide for both containers and operators. So that kind of walks through the whole process of just joining, partner zone, getting the right entitlements, for NFRs, et cetera, as well as what the requirements are to actually go through the container and operator certification process.
Awesome.
And furthermore, if you're interested in doing a certified operator, there's actually a certified operator build guide. It is linked from that first guide, but it's a little hard to find in my opinion, because it's like one link on one page. So I also included the link to that, which goes into great detail and depth on what are the requirements for a certified operator. So for those of us who aren't developing, who aren't creating those, I find this interesting because it gives you a peek and some background into what does it mean, right? What's the difference when I look in Operator Hub in my OpenShift environment? What does it mean, the difference between a certified and a community operator?
Right.
Well, a community operator is one that is basically, the third party submits a PR to a GitHub repo, which is github.com/operator framework/community operators.
I think.
And
yes, it's community operators. I just don't know the URL.
And if I can get that up, and I will post that in here. So the community operators, right?
There we go.
So essentially, they submit a PR against that and basically say, hey, there's like basic testing of will this deploy? Can I create an instance inside of OpenShift? But nothing beyond that. Basically, hey, there is enough validation that it runs in OpenShift, but nothing more. Whereas operator certification or container certification means a lot of additional stuff, all the stuff that's in those documents, as well as a lot of additional testing that happens on both sides, both our third-party partners as well as inside of Red Hat. So it is important for that kind of assurance, background, understanding of what's happening. So I do recommend, if you choose to use the Red Hat operators, that you do a little bit of background reading and just get familiar with that process.
Yeah, and if you want to submit your own, there's the ways to dive in and get that done. So thank you.
Yeah, and also, not even if you want to submit your own, there is also, if you want to create your own and publish them internally, right? What does that look like?
Right.
So I find particularly if you go to learn.openshift.com and do the Ansible operator workshop that they've got published there, it's great for getting familiar with, equating things that we already know as admins, Ansible, into this operator paradigm inside of the cluster.
Exactly, right? Like if you're familiar with operators or Ansible, the leap to operators isn't as big, right? Because normally operators are written in, Go or some programming language, but you can write them in Ansible. You can write them in just about any language nowadays. It feels like there are shell operator frameworks and Python operator frameworks and Java operator frameworks out there. So, but if you're not familiar with the language and you want to do something with an operator, Ansible is the perfect way to get started. And we actually have in our archives over on YouTube on the playlist the Ansible operator workshop that we ran in July during the Summit at Home kind of event that we did. And I will grab a link to that here in a second.
So, Mutasar, I see your thank you. So hopefully that answered your question. Please feel free to reach out. Again, Twitter, email, simply first name last name for me at redhat.com.
cshort@redhat.com. Yeah.
Yeah, if you want further clarification or want us to connect you with the right folks inside of Red Hat. So the question that you were asking, which comes from Waleed, Waleed?
Waleed, yes.
Yep. If I would like to change the install config.yaml to a single node, what do I need to make the router run on the master? So a couple of things inside of there. So one, install config is the file that is fed into OpenShift install to deploy the cluster. So I think it's important to point out that we don't support single node deployments. A minimum is 3 nodes. And it might be possible to do a single node deployment. I want to say that there's a blog post out there somewhere. I don't remember.
There is.
Yeah.
I don't know if it's officially supported.
Oh, it's definitely not supported.
Yeah.
So it's one of those technically possible but not supported. If you want a single node deployment, the recommendation is code ready containers,
right.
CRC. Yeah. So that being said, I want to let's ignore the single node thing. How do we make a router run on a master? So effectively during deployments in the install config.yaml, you want, if you set the number of worker nodes to 0, that will tell the installer that you want to create a 3-node quote unquote compact cluster. So what that means is behind the scenes, effectively the masters are marked as schedulable, so that any workload can now be scheduled to the master. Now you can do the same thing if you're doing more than 3 nodes, if you're not doing a compact cluster. So in your install config.yaml, you would have 3 masters or 3 control plane, 3 workers. You would do an OpenShift install create manifests. So you would end up with the manifest files. And then inside of the manifest directory, there is a YAML file that you can edit that says make the masters schedulable. Right? Yep. You just literally change a false to a true, and you will have a schedulable control plane. At that point, you have really what you would want to do is after deployment. So if you're doing true 3-node compact cluster, so there's only masters and only the and the control plane is schedulable. You don't need to do anything because that's the only place that will run it. If you have that, it's a schedulable control plane, but other worker nodes, you would want to simply modify the ingress controller with a node label or a node selector. Right. So I want you to run on nodes that have these labels associated with them. And that will, for lack of a better term, pin it to those types of nodes.
So there's a message in the stream that it looks like Skynet is talking, but the audio is much better now, so I think I fixed it. So sorry about that, folks. Something very weird happened there all of a sudden. Unusual, the joys of live streaming. Welcome to it. Let me know if it's fixed. It's fixed. Okay, cool. Awesome. So please continue, Andrew. Sorry.
No worries. Yeah, who knows? Could be
FM. That's what we call it.
Yeah. Frequency modulation?
Frequency modulation. Yeah, stick with that one. Yeah.
Solar flares.
Solar flares, FM, whatever you want to call it. Yeah, like it did sound like there was like 2 streams running, so I don't know what was going on there. It could entirely be. I close Chrome? Yeah, Chrome is closed. It's only Zoom and OBS on the streaming rig, so I don't know what's going on there. That's weird.
Okay.
All right, cool.
Okay, so I don't see any other questions at the moment. I don't think I missed anything. So
no, I don't think so either.
Please shout if I did.
Yeah, your questions are very, very welcome right now. We are all about answering your administrative or other OpenShift questions, and if we don't have the answers, we will find them for you and get you in contact with the people that do. That's the most wonderful part of OpenShift TV.
All right, so I promised a conversation about Red Hat Enterprise Linux CoreOS, or as we abbreviate it, RCOS, or most often we just call it CoreOS. So if you look in the documentation, you can see that I'm just at the landing page for the OpenShift 4.5 documentation. Underneath the architecture heading, we have this Red Hat Enterprise Linux CoreOS, which walks through a number of different aspects about CoreOS and the differences, the changes, right? Why it's important to OpenShift as a whole. So first, I want to point out that CoreOS in the context of OpenShift is required for the control plane, but not required for worker nodes. So you can use RHEL 7 worker nodes inside of your cluster. However, in general, and I think most Red Hatters would agree that the benefits of CoreOS, of Red Hat Enterprise Linux CoreOS, far outweigh, right, the little bit of additional flexibility you get with using rel 7 for those worker nodes.
Right.
Now, there's always edge cases, there's always exceptions, there's always, right, all of these things, and you're not doing anything wrong. There's nothing, inherently bad about using rel 7 worker nodes. You just lose some of that, again, flexibility, manageability, or excuse me, you lose some of the manageability and automated operations to gain some flexibility associated with that.
Right.
And we know that CoreOS is a different paradigm. Sometimes there's a learning curve, and
It is
that's
a
okay.
different way of thinking, and that's fine. Yeah.
Yeah. So CoreOS is very much like its lineage. So modern CoreOS, Red Hat Enterprise Linux CoreOS, like its lineage of both CoreOS from CoreOS the company and Atomic Linux, is an immutable operating system. Right? It is intended to be deployed and have basically a known state. And I want to be clear that immutable does not mean that it is unchangeable.
Right. It's not unmaintainable.
Yeah. So here, I'll show this slide here, which we created a while ago. Right. Immutability does not mean that it's static. It doesn't mean that there is no configuration change that's happening there. It means that it happens in a controlled manner. And it means that we can predict, right? We should know exactly what the configuration of that node looks like at any given point in time.
Mm-hmm.
So this is hugely beneficial for something like OpenShift, where
Right.
my nodes, much like my containers, can be treated as disposable. Right. I need to change the config. Well, it's basically going to reapply the entire configuration for the node with every change. When I go and do an OS update, it's going to reapply the OS using our PM OS tree, right, into the node. And then we simply switch over to the new operating system. Sanjeev, what is the best way to set up OpenShift 4.5 in a closed environment?
I've got a video coming. Hang on.
Okay.
Because I got to clarify if he's on premises, and I'm trying to figure out on premises how to spell that. Hang on.
PREMISCS.
Yeah, I got it. It's
why do I know this? Because I used to work for a storage company, and we made a big deal out of it.
Yep. This stream suddenly caught my attention, according to Mobile Curry.
Well, I hope that's a good thing.
Yeah.
So to answer your question about disconnected, so the best way to do it is if you look in the documentation underneath installing, and then we go to installation configuration, there is this creating a mirror registry for a restricted network. So this page, this documentation page, details how to take all of the images, right, all of the things that we need to instantiate, to deploy OpenShift, and bringing them onto a private network, whether that is fully disconnected or partially disconnected. So partially disconnected, and meaning that there's a host that straddles, the internet and your private network. So one thing to note about this, and this has come up a number of times, I've answered a bunch of questions about it internally, of when you look down here, it's not obvious at first. When you get down to step 3, where it says mirror the version images to the internal container registry, there's a couple of commands here. So the default one, the first one, you see will release or will mirror them to a local registry. So this is intended for the scenario where my internet connected node straddles internet and private network. If you have a fully disconnected, air gapped, whatever you want to call it, network, you want to use this command down here, which you see uses the dash dash.
You blow up your size a little bit because it's even harder for me to read. Sorry. Probably should have said that sooner. My bad, audience.
No, you're good. Yeah, apologies. So you want to use this command down here, which you notice uses the dash dash to dash dir, or tac or hyphen hyphen, whatever word you want to use for this character.
Whatever you want to call is fine, Andrew.
So this will take all of that data and metadata and put it into a directory, on a USB drive, on a portable hard drive, whatever you want to use. You disconnect that from the internet connected machine, do whatever your internal process is for scanning, security, make those security guys happy. And then when you get it to the other side, the disconnected side, you use this dash dash from dash dir to import from that location. And then after that, and it explains this in the documentation, there is a chunk. So up here, it actually tells you. When you do the dry run, sorry, it's hard to find, and I know it looks like a lot of scrolling because we're on this, on my screen is
size,
gigantic.
Yeah.
So when you do the dry run, it will spit out, and actually when you do this command as well, it will spit out a chunk of YAML that you want to put in your install config. And that is what tells OpenShift during the install to look to this other registry, not the default Red Hat public, Quay.io registry for all of its stuff. So basically 2 steps. One, mirror all of the stuff, or 3 steps, excuse me. One is pull all this stuff down to a local device, whether that's a removable media or a local registry. 2, if you are, or 1A, 2A, if you are fully disconnected, right, move it over to the disconnected network and then import it all into a local registry. And then step 3 is add the stanza to your install config so that it knows that it's a disconnected install. So
chunk of YAML should be the
it.
war cry of Kubernetes.
Yeah. So I will add, so let's jump up to the top. Sorry for the quick scrolling there. So I will add that only addresses the install portion. So getting OpenShift up and running. If you want to use Operator Lifecycle Manager, basically the package of, or the set of operators found in Operator Hub, there's a separate set of instructions for that I can never remember where they're at in this documentation. Maybe it's operators.
I think so. Could do a find. That just makes sense.
There we go. Using OLM on restricted networks.
There you go.
So this walks through basically the same process, just with a slightly different command of identifying. So first turning off the default operator so it stops trying to connect to the internet and pull them. And then on that internet connected machine, on that public machine, pulling in all of that data, metadata, right? Storing it locally, moving it over, and then importing it on the disconnected side. But you only need to do that if you intend to use any of the Red Hat operators. So OpenShift virtualization, service mesh, Elasticsearch, the logging rate suite, etc. And you can be selective with those. So if we were to do OC get catalog source, so you can see here's my catalog sources. And if I wanted to have just the core Red Hat operators, well, then I only replicate this particular catalog source. If I don't care about the community operators, if I don't care about marketplace operators, I just don't mirror those. So pretty straightforward in that respect.
And there's 1,001 ways to get images and content over to a disconnected network, right? Like we've seen people do thumb drives, we've seen people do spinning hard disks, like USB drives, DVDs, you name it. We've even seen people like maintain, like copy the registry as exists, like on, the connected side, and then just replicate that as like a snapshot or something into the new environment, which I've always seen interesting. But
print off ones and zeros and retype them.
Yeah, there's always that. I've got a punch card here nearby.
That's just torture. That's no.
Yeah. So let's see. I want to make sure.
So I'll jump back up a little. Just
Scooter
looking at
Phoenix, and then Mobile Curry. Mobile Curry was before Scooter Phoenix.
Okay.
So Mobile Curry's eyes are now open to immutable operating systems. Never heard of that before.
Yeah. So the concept is you want an operating system, or you want something that is not easily modified outside of the change process. Ideally, it cannot be modified outside of that, but especially if somebody has root, right? It's still Linux at the core. There's still things that you can do to abuse the system, if you will. So inside of the OpenShift paradigm, CoreOS is managed by the machine config operator. So effectively, what happens when I go to install CoreOS, it installs the operating system, but it has no configuration. right? It's just the kernel, the drivers, right? The other libraries that it needs. And the first thing that needs to happen is it reaches out and it pulls down an ignition config.
Yeah.
So you can think of ignition as being like Cloud Init, if you're familiar with Cloud Init, right?
Yeah.
Or the various other tools that are out there. I know there's one for Windows and for various other things. I don't know what you're holding up, Chris.
I'm holding up a punch card for narrative.
Yeah. So with the goal being, and what's really interesting about Ignition that's different from Cloud Init and most of those others is it runs before the system is fully booted. So before PID 1 starts, Ignition does its thing. So this means that we can use Ignition to lay out things like unit files so that I can start or stop, disable services, so that I can put configuration like networking, etc., all into the file system and then hand over and let the system boot as though those files had been there the whole time. So this is kind of the paradigm that we adopt with OpenShift's machine config operator and CoreOS. Of the administrator manages the CoreOS configuration via Ignition, which is managed by or deployed by machine config operator. So the end goal here, or the end result here, is we can always predict what the configuration or what CoreOS should be configured by looking at the machine config operator. So let me bring up my console here, and we'll take a look at what one of these looks like. And I will go ahead and boost the size of this while I'm here. Come on, browser, catch up to me.
You can do it. I believe.
My poor 5-year-old MacBook Pro is not happy.
What?
But
Why are you using a 5-year-old?
I get a new laptop on Friday.
Oh, you do? Good.
So if we come down here to the compute section and we look at these two options, so machine configs and machine config pools.
Yes.
And these will exist regardless of whether you're using bare metal, UPI, IPI.
So they'll always be there. Yeah.
Exactly. And this is cluster was deployed. It's deployed onto Rev using the bare metal method. So these always exist because this is how we configure CoreOS. So we can see in machine configs, I have a number of different objects that exist inside of here. Helpfully, they tell me by the name what they pertain to, but we can also look at the contents inside of here. So for example, if I were to look at the worker kubelet machine config inside of here, and I look at the YAML associated with it, what I'm going to see after I get past all of this managed fields nonsense, thank you Kubernetes 1.18, what I'm going to see is a bunch of different things, right, that are telling, this is Ignition, which is YAML, telling it to lay out contents, right, files. So for example, here it's saying, put a file at etc kubernetes cloud.conf that is owned by root with an access mode of 4.20. So what is that? Read, I don't know what the 2 is. Read, execute, nothing, I think.
2? I have no idea. It's like less. No,
I think
it's like super privileged or something.
Yeah, I think it's read, execute.
Hey,
Anyways,
nah.
And then
I could pull up that Wikipedia page.
The contents of that file is this. In this instance, it's a URL encoded file. Right. I could also do base64. We can see down here, there's plain text, right? It varies depending on any number of factors. And I don't think there's any one way that's better or worse than the other. So we can see here, right? Hey, create this file, cloud.conf. Hey, create this file, kubelet.conf, right? Here's the contents. So Ignition will go through and ensure that these files exist and lay them out and make sure that they have the contents that they are supposed to have inside of here. And what we end up with is, I wanted to look at one other thing while I was there. So if we look up here at the top, not managed fields, we can see this labels. So this is how it determines which nodes this is going to apply to, right? This is effectively a machine selector or a node selector. So the end result is I have this rendered config. Right. So down here, I have this rendered worker config. And if I got to look at this guy, it will be the sum. It will be all of the machine configs that are tagged for workers added into one file. So we can go through and you can find all of the things, all of the configuration. Right. Here's my registries.conf. Here's the cloud.conf. Here's a bunch of systemd units, right, that get added in. Here's what is this one? Starting different things. I'm just randomly scrolling through here. So that rendered config is then what's used to apply, and you can see this is used to apply to the machines in our pool. So a machine config pool is a group of machines and a configuration that are mapped together. So how does this actually apply during the install process? So I deploy my CoreOS. So let's say that it's the bare metal method, right? I boot to that ISO. I hit tab so I can edit the kernel line. And then I append ignition.cfg equals, I think it's ignition.cfg equals. And then I point it to where this file is being served from, right? Which by default, if it's an existing cluster, is going to be, api.cluster name domain name port 22 something. It's all in the documentation. I don't remember it off the top of my head. And then basically what happens is it boots right during the that initial kernel load. It reaches out, it pulls down that file. Ignition executes that file, right? It puts down all of the things that are inside of there, and then it hands over to the rest of the system. So we get asked things like, well, how do my nodes get assigned their host names?
Right.
Well, if we're talking IPI, that's managed by the machine set, right? The machine API integration and the machine config. So effectively, when machine API says, create me a new virtual machine, and it has CoreOS on it, and then it boots up, it pulls its machine config and says, you are node worker 12. And it configures itself with that host name. So this is kind of how all of these things flow together to get to that point. Now, I've seen the chat scrolling. I'm assuming you're keeping up with it.
Yeah, I got it.
Okay.
It's mainly Christian. Narendev's in there too. He created a highlight for us. So yeah, thank you, Narendev. Also, my mouse is like on the fritz suddenly too. Dang Bluetooth.
You have more equipment problems than anybody I know.
Dude, it's getting better, but it's not there yet. So I have backups of everything, right? Like, oh, here's the nice mouse that doesn't give you carpal tunnel. It's not working. Okay, here's the old Apple mouse. Here we go. Back to business.
So yeah, how many microphone arms did you go through? Like 3 in a 2-week span or something?
I went through 3 in a 2-week span. This is microphone arm number 5, but keep in mind, one of those microphone arms is now Christian's microphone arm, and he is having problems with it. So it's not just me.
But it was yours, so it could have arrived.
It could have been me, maybe. I don't know.
So, well, I see the new one is a Heil, so hopefully it's working for you.
Yeah, I don't like the fact that they like plastered their logo all over it, and I can't, and it's like, concave, so I can't like get a sticker to fit over it just right either, right? Like I would put like, a Red Hat or OKD sticker or something, Kubernetes sticker on top of it for all I care. So maybe I'll do that this weekend with an X-Acto knife and try not to cut myself open.
Aubrey, my PMM counterpart, she has a monitor, the back of a monitor, which is where her husband works on the other side of that monitor.
Oh, nice.
She put a Red Hat logo sticker over the monitor manufacturer logo.
Yeah, so, man, like that makes total sense. I would totally do that, right? Like I'm not here to advertise for, LG or Samsung or whoever, right? Like
yeah, or Heil.
Or Heil, right? Like, yeah, you know what? This is gonna get fixed today. You're putting this on my list now.
Yeah.
So Willie's got a question. Yeah.
Okay. And I see in chat, thank you, Christian, for correcting me on what the correct on the appropriate kernel parameter for providing the ignition URL is. So thank you.
Yes. So
And
Waleed's question is, speaking about machine sets, what would be the best way to run stateless workloads on spot instances, as in diversifying them over AZs and instance types? Whoa. That's a deep question.
Yeah, so spot instance support, I think, was just added, if I remember correctly. I think it's 4.5 was when that was introduced. So effectively, to my knowledge, spot instances are really no different than any other, node type, or machine type, I should say. Aside from in the definition, it's saying, yes, use spot instances here, and of course they can be reclaimed by the by AWS at any point in time.
Yeah.
So my assumption is you would want to have, and to be clear, I haven't tested this, so this is based off of an educated guess. So you would have machine sets. So if you're not familiar, machine sets are what define to machine API operator how to or what to request from the underlying infrastructure. So I don't have a cluster deployed that has any integration with machine sets, so I can't show it. But essentially, in the case of AWS, it's saying I have a machine set. It's for this AZ in this region. I want you to create a new machine that is of this type that has these other properties associated with it. And when you request that OpenShift scale that machine set, essentially Machine API says, okay, I see all of these properties. I'm going to go to AWS API and say, provision me a new one of these. So if you wanted to distribute those across multi AZs, you basically have to have a machine set per availability zone. Yeah. And then for the burstability, right, stateless aspect, essentially you configure auto scaling. So auto scaling is configured both on the machine set level as well as at the cluster level. And then there's some intelligence within, at least I've been told there is, I haven't experimented with it, of it understands what type of node to provision based on the scenario. So if I'm deploying a workload that needs a GPU, it understands that I need to deploy a machine from a machine set that has a GPU attached to it.
Yeah. I think the crux there is like the machine set in each availability zone already existing. And like it doesn't necessarily have to be on, right? Like that's kind of the beauty of spot instances.
Yeah, you can scale to 0 as well.
Right. Yeah. But you have to have that set up, right? And once you have that, you are able to scale up. So Narindev is asking, what is a machine set? So that's a great question, as a follow-up to this.
Yeah. So in OpenShift nomenclature, and you can see on my screen here, we have nodes, when we have machines, and we have machine sets. So a machine set is a definition. You can see this is not I don't know why I clicked that. It's not a cluster that has one. So a machine set, much like a daemon set, much like a stateful set, defines the template that it will use to create something. So with a stateful set, that template is, here's the pod definition, here's the PVC definition. When I scale that stateful set, when I go from 0 to 1, it will create the PVC, it will create the pod definition according to what's in that template. When I scale from 1 to 2, it creates another one, right? So on and so forth. Machine sets do the same thing, right? So what is the difference between a machine and a node? So a machine is the representation of the infrastructure object. Basically, it's the virtual machine, or whatever in the future it'll be a physical machine, right? So it is a virtual machine that it understands has properties with that underlying infrastructure as a service provider. The node is the traditional Kubernetes, right? I have nodes in my cluster. So a machine is the virtual machine and how the cluster interacts with the infrastructure underneath. So created a machine, destroy a machine. The node is after CoreOS has been deployed, configured, and it's joined the cluster and becomes a productive member of the cluster.
Nice. So Waleed has a follow-up. Machine set per AZ. Got it. But would it also be per machine type?
Yes.
Yes. Okay. So you would have machine sets, machine types under machines, and then that would all be scaled to 0. And then you would grab spot instances as you saw fit.
Yes. And remember, they do take a little bit of time to spin up,
Yeah.
usually 3 to 5 minutes, I think.
So yeah, if you don't do spot instances right, you could end up spinning up spot instances and then having them taken away from you before the cluster is even online. So you got to make sure that config is set up.
Yeah. And I don't know, I know the other cloud providers have similar concepts. I think Azure calls them low priority instances.
Yeah, there's
I
everybody
don't
has them now.
I don't know if all of those others are supported by OpenShift. I do know spot instances with AWS are.
Yeah. Narindev is asking what is an AZ. I'm saying AZ is availability zone. Think of it as a data center. So, for example, GCP, AWS, Azure, they have multiple availability zones within each of their data center locations. So, what does that mean, right? Like if US East 1 is the DC region or the Eastern Seaboard, they could potentially have a data center in, DC or any one of the multiple areas around DC or the East Coast in general and use that as an availability zone. The idea is that within those availability zones, there's lower latency and higher throughput potentially than it is when you cross the regions themselves, like US East 1 versus US East 2 kind of thing.
Yeah.
Yeah, I mean, I feel like I did a good job of that. I might have missed some points there. So, Andrew, please feel free to add on.
Yeah. Christian uses the word failure domain. So you
I
can
like
think
that
of it
one. Yeah.
as, it doesn't have to be a full data center. It could be, if we're thinking in terms of, my local data center
Yeah.
or your local data center, it could be a single rack.
Yeah.
Right?
It could be a rack in someone else's data center for that
Yeah.
matter. And I used to work for one of those companies where Apple had a presence in a data center. Yeah.
So, when I was a customer, right, we based our quote unquote availability zones based off of the power distribution, right, of each PDU served somewhere between 8 and 12 racks. So we wanted to be able to accommodate a PDU failing.
Okay.
Which did happen.
That does happen frequently. All right.
So, if we lost 8 racks simultaneously, is my infrastructure, so maybe it's Rev or VMware or something like that, are my clusters, the physical hardware that make up those clusters, my DRS clusters, spread across those AZs so that I can tolerate that failing. Same principle with OpenShift, right? Of are my nodes distributed across those availability zones so that I can tolerate failure at that level.
Yeah, so it's like, Ryan Jarvin's on the call, or on Twitch, US West 1, US West 2, US East 1, but this is like the ABCD behind that, right? Like, so I know US East 2 has like 4 regions and AWS and like GCP Central, which is my local region for GCP. I think it has 3 availability zones, maybe 5 now. Yeah, PDU. Sorry, we're using acronyms, and people might not understand them these days. I, didn't even think about that. Right? Like, what is a power distribution unit? AKA, it's a big ass power strip. It's an enterprise power strip with potentially monitoring and all kinds of fun stuff in it, like IPMI, which is a fun little protocol on of itself. So they've gotten rather complex.
Because there's the main power distribution for the data center, which sends, in the data center I worked in, would send a few hundred amps of 3-phase 208 to each, basically the end of each rack row. And then that PDU would break it down into 40, 50, 60 amps of one phase that go to each of the 2 power strips in the rack. So if I'm looking at the back of my rack, I have one power strip that is on phase 1 and one power strip that is on phase 2.
And then I can source from each one of those, and gives us some redundancy at that level. If I drop a phase, if I drop a PDU, it's not going, or excuse me, a power strip, it doesn't affect it. But
right.
Data center architecture.
Data center architecture is something we could talk about literally all day, but we got 10 minutes left. So if you have any questions, feed us our way. Anything else you want to talk about RCOS or Red Hat CoreOS, I should say?
There's a ton of stuff that we can talk about. Usually the biggest one that I try to communicate to people is Red Hat Enterprise Linux CoreOS. Like, that naming is not an accident. It is based on RHEL 8. It is the same kernel. It is the same drivers, right? All of those other things. And importantly, for us administrators, it has the same underlying tools for doing configuration management. So what do I mean by that? Well, you saw, where'd my thing go? So you saw in my machine configs here, right? When I'm looking at the contents of these machine configs, I'm just laying out standard files, right? If I need to, here's a good one, iptables.conf, right? I'm just laying out files the same way that I always am. How they're getting there is what's different.
Right.
But at the end of the day, it's still RHEL.
It's still RHEL.
When I need
files.
Exactly. And when I need to make modifications, when I need to configure that host, I'm still modifying it in the traditional RHEL way, or excuse me, I'm still configuring it in the traditional RHEL way. I'm applying that configuration in the OpenShift way. So I think it's also important to highlight that CoreOS nodes, right, machines in the OpenShift paradigm, are meant to be treated as disposable.
Yep.
So effectively, most configuration should be dynamic, right? Should not be static. Right? I shouldn't be going in and modifying individual files on individual hosts. If I'm having to go in and create a specific machine config pool for worker 0, worker 1, worker 2, worker 3, because each one of them is different, then that should be an indication that something, right? Maybe we should reevaluate how we're doing this, because that's not the intended way of how we manage those hosts. So I think it's particularly important to remember, and I think I've said important like 4 times now. So there are some things that should always result in the node being reloaded. So for example, the first network interface, the one that that sits on the machine cider. So if we look at our install config,
threw out another thing, cider. I don't even know what that stands for anymore. So you
common
get a
internet
page.
Domain. I don't know. It's the subnet. Yeah, it's the subnet.
Classless interdomain routing. So it's a subnet address basically, and I'll try not to give you a borky weird link this time. I'll give you a clean one without all the ads and nonsense. So yeah,
it's not. So it's not actually defined in this config. Let me see if I have one that does have it. No, it doesn't look like it. We'll try this one.
What are you looking for?
I'm looking for, here we go, machine network, machine cider. Yeah. Okay. So essentially the network interface.
These aren't drinkable. These are networks.
So the network interface, the NIC on the machine that sits on this network, is the one that will be used for the SDN. It will be the one that it's expected to connect to the control plane with, right? There's a lot of things that are dependent on that. If it's wrong, most likely your cluster will still deploy fine, but some things might not work as expected. In particular, and especially if you're using a proxy. Basically, by default, it will say, I'm not proxying anything that's on this network. So if you accidentally have this wrong and then you suddenly implement a proxy, you'll end up with a bunch of nodes disconnected because they think they need to proxy to get to the control plane. And yeah. So if you need to change, for example, the IP address, so I'm using static IP assignments. I need to change the IP address for the network adapter that sits on this subnet. That should be a reload, right? Basically, blow away the nodes, right? Destroy it, or reload the operating system and provide that static IP address again at that kernel parameters line and let it implement it that way. And remember, we're using machine config pools. Basically, that's the only configuration that you need to do, right? I give it the new IP address, it pulls that configuration in, all of it gets reapplied just like it was before. The workload, gets rescheduled over to that particular node, and we're good to go with a couple of minutes of downtime, basically.
Yeah,
So,
I mean,
yeah, it's one of those, we have to think about managing those nodes a little bit differently, in that we want to be very careful about creating, and I know everybody loves the term snowflakes.
yes.
We want to think about managing at scale, managing nodes homogenously. So that's, and they don't all have to, right? Not every node in the cluster needs to be the same, but within the same machine config pool.
Right. Like you can have different machine instance types in the same node pool based off your needs, right? Like GPUs versus, regular, whatever instance left. So Waleed has a question. We only have 5 minutes. Maybe next session, I will ask about the proxy. Thank you all. Love this edition and diversity of the session. Much appreciated.
Yeah, happy to talk about the proxy. I can cover it at a high level.
And
I've
Scooter Phoenix said that they love the way you're explaining things. So this show
thank you.
very much appreciated on this channel. Thank you so much.
You English like I do.
Yeah, I English bad.
Yeah, thank you. I really appreciate that. And please don't be afraid to ask clarifying questions, because
that's what we're all about.
And
there's no such thing as a dumb question on this show.
I'm the king of dumb questions, as you all know in our private Slack. Yeah.
Well, this morning I might have you beat.
I've asked that question before.
Yeah.
For reference, we're talking about demand gen.
And, what is that?
So the proxy. So we had.
We only have 3 minutes. Can you do it in 3 minutes?
I can touch on it in 3 minutes.
Okay.
So we had a number of questions come up about using proxies with OpenShift. So effectively, proxy is pretty straightforward. I've got a config. I'm not going to show it now because the VM is turned off, but I will show deploying it next time. But effectively, if you're using a proxy to access the internet, it's pretty straightforward in that, and I'll just pick any one of these, right? I'll do one up. I'll use your proxy. Or your search, which didn't work for me. It took me to the operator lifecycle manager proxy config. Cluster-wide proxy. So you can configure the cluster-wide proxy either at install time or after install, depending on what you're doing. So you can see here, if it's after install, pretty straightforward. Create a proxy object that has your certificates if you're using, man-in-the-middle proxy. And basically the cluster configures itself. If you want to do this at install time, you're doing it. Sorry for banging on the microphone there. If you want to do it at install time, you put that same information inside the install config.yaml.
Cool.
Let me see if I have an example of that real quick. Oops. So we can see here, just at the top, I have a proxy with the trust bundle that goes along with it. So very straightforward. The biggest, most important problem that everybody has, and I did this myself when I first deployed it, make sure that you set no proxy correctly. And by that, any networks, every network that doesn't need to go through the proxy needs to be defined here. Theoretically, the network that matches your, again, machine CIDR or machine network defined below doesn't need to be in there. I put it in there just to be safe. But if it's not in this list, it will try and proxy to it. So if your workstation is in a different network, if your HTTP server for Ignition, right, is in a different network, all of these things, it needs to be in this no proxy. Otherwise, you will have issues.
Big issues. All right, so it's top of the hour. I got to switch over to OpenShift Commons briefing, which is going to talk about Instana. We've got Matthias Lubkin. I'm pretty sure I messed up his name. I apologize, but they are up next to talk about the Instana operator. So thank you very much,
All right.
Andrew. Appreciate your time today. Sorry for the hard cutover.
That's okay. And thank you, audience. Really appreciate all of your questions. It's been phenomenal. And I will see you next week. Same time, same place.
Awesome. Diane, I'm hitting you up here in just a second.